So, okay, two people, it's okay. I think we can start, and other people will just watch the recorded lesson, or maybe will join.
Okay.
Okay, so give me a second. I think now it is. You can see my screen. So.
Yeah.
Okay. On this seminar, we will discuss we will continue discuss usage of large language models. And if we talked about Llama on previous lesson, today I will demonstrate how can we use Mistral model. It's another architecture. It's decoder only two transformer, but with some changes in the architecture. So we will explore in Mistral's suite of models, focusing on text generation, embeddings, code generation with CodeStral and image analysis with Spectral. Mistral AI has developed these models to provide high quality open source alternatives to other popular models like Llama. And we will learn understanding of large language models and their use cases. We will learn to work with Mistral's API tools for generating text, embeddings, quote and vision data. And also we will understand where Mistral models differ from other large language models, including the specialized quote and vision capabilities. So Mistral AI is a company focused on creating open source, efficient, and high-performing large language models. The company aims to provide models with fewer parameters that still outperform many larger models, offering accessible, scalable tools for the broader community. And if we will compare it with Llama model, we can start from the performance. Mistral's models, such as Mistral with 7 billion parameters, excel in common sense reasoning, world knowledge, and code generation, often outperform larger models like Llama of second generation with 13 billion parameters. But I think it's underperform Llama of third generation. If we will discuss parameter efficiency, Mistral's model achieve high performance with fewer parameters, making them more cost effective for various use cases. And both Mistral and Llama are open source, but Mistral's models are increasingly not for their ease of use and application. So they changed some things in the architecture when they created Mistral. And one of this architecture is attention, changes in the architecture is attention. In Mistral model, they use grouped query attention. So I will show you what is it. So it looks like, yeah, on this On this visualization, we can see how looks multi-head attention. We have a lot of heads and do multiplications in each head. When we have grouped attention, we group some heads and we do less multiplications in this case. So we need fewer, we optimize model and we optimize its complex time of multiplications in the model, and also we optimize RAM and memory when we do it. So it's more efficiency, and as you can see here, there are some theses which demonstrate that group query attention is better than multi-head attention. If you're interested in, I can share a paper with you in the Telegram chat. So here we can you can read what is it and how does it work. And you can see some metrics with other architectures and comparisons with other techniques. So let's continue our lesson. Firstly, I setting up the environment. I will work in the Google Colab today, and you can also work there. But if you will work maybe on your own Jupyter Lab a machine, or with on your own machine with on the service with GPU, you can use not this code block. You can just use terminal and set up your API key there. So we will stop it like this in the Google Colab, but I did it in the beginning of the lesson before I demonstrate the screen. And I will explain you where you can find API key on their site. It is free. It's there are some changes with OpenAI key. If on the OpenAI site you need to pay for tokens which your model will generate. Here you have here on their documentations we can go to the La platform. It's by the way, it's a French company, so and you can see on their site that here we can mention it. So you will see here API keys, and when you will go in through this button, you will see billings, and there you can see a free plan of usage. It means that you will not have some abilities to fine-tune your model via API, but you will be able to use generation as this. And I think it's nice when you can use some clever models just free and without any other without any other actions to use it. So yeah, we can follow these steps to set up environment. We'll install necessary tools, and of course we will register it on their site and get an API key. Then we'll store the API key securely as an environment variable, like here. And it will protect you from some issues if you will commit your code on GitHub. Please don't commit API keys, because everybody will use it, and sometimes if you will commit keys, there may be some set actions then, because you will pay for tokens which will generate other people. So here we can see then once the environment is set up, we can initialize the Mistral client to interact with various models. So here we can see Mistral, the main class for interfacing with Mistral models, and client, a variable instance initialized with the API key, which allows us to send API requests for text generation, embeddings, and more. Here we can start with text generation. Text generation allows us to provide a prompt and have the model generate text. This can be used for content creation, answering questions, or even simulating dialogue. And we can run it. In the prompt, we had a question about cheeses in the French cheeses. So it will run right now, and then we will see a response of the model. It's a list of the most famous cheeses in France. You can read it. You can then at home change prompt and ask something else this model. But I will explain you what is going on here. Here we have Mr. Large latest model. It's a strong choice for general purpose text generation. And also we defined the user prompt. In this example, the model provides a list of franchises. I insert here some exercises, but I did it by myself. You can at home you can do some changes in the initial code and create something else. So the first exercise was about list of popular travel decisions in Paris. And you can modify prompt at home and play with other examples. So also I insert the example how to prompt the model in different styles. We can generate responses in formal and informal tones to see how the model adapts its styles. And here you pass style in your prompt. You can do some different actions with your prompt. Maybe you want generate story in some style, or maybe here we can insert not the style, some other details, and then we can go for the cycle of these details, and from for just change each insert in the time. So here I can run it and see some examples of formal and informal responses. Let's wait for the answer. And yeah, here we can read formal style response. And also, don't see, yeah, in informal. If you want, you can print it in another another styles. So you can also do here this tag that will print answers of your model on. Okay, let's see how it would be in the printed way. It will skip some space. Okay, we will return to it, and then I will continue. Okay, you can see here how would it how it would be. Okay, here I inserted examples of embeddings, generating embeddings. You need to remember how we can get embeddings from different models. For example, we can use Word-Vec, we can use TF-IDF for embeddings, or some encoder-only models, but also we can get embeddings via decoder-only model too. But we'll have some changes from other options how to get these embeddings, and I will explain you, but little bit. Okay, we will go through what is going on here, and then I will explain what changes we will have in these cases. So embeddings represent the semantic meaning of text numerically, which is available for tasks like similarity, measurement, or clustering. And here we have inputs. We have two sentences inputted in the model. We use Mistral embedded model, and it's optimized for embedding generation. And here we will get embeddings. We can print it, and looks our vectors in the latent space. So it works like getting embeddings from encoder-only models. For example, from the BERT, you just use embedding layer, and then you do pooling, min pooling, or max pooling, or some other operations to get your vectors in the latent space. And here we can do the same way. We will use just embedding layer in the decoder-only model, and do some min pooling operations or other. But not a lot of people know that there are some changes in the usage of decoder-only embeddings. I mentioned it when I worked on the project when we did search engine for the code, yeah, just code languages, and we wanted get embeddings from decoder only model, and then search okay, we embedded prompt from the user and searched in different embeddings that we had in some we had functions from the code, and we searched it with, for example, vectorized databases. So we used FAIS, for example, for this, but there was some important, one important changed in the meaning. We mentioned that when we search with decoder only embeddings, we had the same texts in the beginning. So if you will use encoder only model, it will understand the whole text that you have and will search from the meaning of this text. But if you will use decoder only model, you will mention that you will have some very similar start in the sentence, in the text. Like, for example, if I will search here for the similar sentences, I think the most similar will be something like this for the first sentence. Like, if I will just change the sentence, change words here, how does it looks, but I will have the same words in the beginning. And something like this will be very similar to the first sentence if I will use decoder only model. But if I will use encoder only model, I think the most similar here will be okay, if it will not influence on the words that I use, it will be influence on the meaning of the whole sentence. Did you get the change that I wanted to explain you? If I explained it not clearly, I can try to explain it in other words. And
can you explain it again? Sorry.
Yeah, okay. So if you use decoder only models, they have some okay, I will see how this works on the English. Okay, it's like okay, they have their own feature or characteristic. I don't know, Google Translate say me that it's would be on English, something like this. And there are some changes from the way how encoder only when you use encoder only embeddings, if you will search a similar sentence for example, this sentence, it will apply on the meaning of the text, and you will get similar information, but it's not matter what words are here. You will just get the most similar sentence for the meaning. But if you will use decoder-only model, it will print the most similar sentences in your databases. It will look like the existing initial sentence, but with some changes in the sentence, if you will change words here, it would look similar for decoder-only model because it apply on the word that model see in the sentence. And it's like this because there is different types of attention in these models. Did you get what I wanted to explain?
Yeah.
Yeah, okay, it was a little bit hard for me. Okay. So yeah, and let's continue if you understood. So here we can see exercise, and I could demonstrate, for example, clusterization here, but we had only 2 sentences. You can encode more, but I decided that it would be just 2 sentences. And I want to measure, calculate their similarity using cosine similarity from girafe-ai library. So we can do it. We will have cosine similarity like 0.9, and we can see it because the meaning of sentences is similar, and we just reformulate some words, but here we say about temperature in these sentences. But let me show you what will be if you will just change words in the sentences. For example, I will pass for the model something like this. I will set climate here, and okay, let's try to get similarity from these 2 sentences. It's higher than it was, but if you will try decoder-only models in real projects, you will mention that feature that I explained to you. And also, if I will choose what to use as embedded model for my projects or for the real project in companies, I will choose encoder-only model to create embeddings and to store them in the vectorized database. And also, it's not only because the quality of this embeddings, it's also because if you will use encoder-only model, it would be a little bit faster, because right now encoder-only models have fewer parameters that large language models, of course. In large language model, we have around 7 billion parameters, and in BERT-like models, we have only, I think, in large version, we will have just maybe 300 millions or something like this. Okay, let's continue. So we measured cosine similarity and we played with embeddings from encoder-only models. Let's build a chatbot. And a simple chatbot can maintain conversational context by storing previous interactions. So here you can create at home your own chatbot. So here I utilized conversation memory by appending each new interaction to conversation history. Conversation history is here, and I appended on every step, so the model will maintain context. Also, I have a function output generate responses based on cumulative conversation history. And you can test the chatbot by asking the sequences of related questions. And you can see how it adapts to the context. At home, you can play with this chatbot and create your own conversationals. So let's see what else I have in the notebook today. Here I wanted to demonstrate to you code generation with CodeStral. It's a model of Mistral company, which adapt on the code generation. And it's like Mistral's code generation model supporting over 80 programming languages. It can perform fill in the middle task or code completion. Off top, I will tell you that fill in the middle task, if you will explore this brain of code generation models, you will meet fill in the middle task as a task for pre-training these models, and you can read some papers. For example, let me remember which code models I can say. DeepSeek coder, they have this task in their pre-train pipeline. Also, I think CodeStar, or no, how does they name? Let me check. CodeStar model. Star coder. Sorry. Yeah, I mismatch the name. Okay, yeah, Star coder, they have this task in the pre-train. So it's just off top and you can read this in the papers. So yeah, we can practice in the fill in the middle task. Here we have prompt and suffix, and CodeStral generates the missing code between prompt and suffix. Also, we have parameters. We adjust temperature and top P to control randomness. It's a ways of how we can sample the output. And I think I can explain you on the stage which ways of sampling do you have. I can recommend you blog post about this. Maybe it would be Sampling. Yeah, it's nice blog post where you can read about different types of generate like sampling the text generation and how model understand which token it would generate on the next step. And here I will just explain you the main types of sampling. The first one is greedy search. As you can see here, we can predict not like on the greedy search, we predict the highest probability of the token on each step. But here we can predict different ways, and we will have a number of beams that we want to generate. And here we have 3 beams. Like on every step, we generate 3 ways of and like of next token, and then you generate on the next step 3 more tokens from the previous, and in the end you have probabilities. The higher probability of the each way will you will just sort it, and you will always have 3 highest ways or in the summer. You will sum all these probabilities, and you will choose 3 highest ways of the prediction. So then you have top sampling, and here we will have top key, top key. So here you will set threshold of the numbers of tokens that in which you will choose the highest probability token on each step. If I will set here 40, I will always choose for the most top of the 40 most highest probability in probability tokens. If I will set top P sampling, I will have threshold not for the number of the most highest, not number of the tokens with highest probability. I will have a threshold of the probability that I need to have these tokens. So I will choose tokens with more than 0.92 probability. And then here I wanna explain you temperature also. Temperature here. So temperature, if I will explain you just the meaning of this parameter, you can read the formula and how does it work on the model sampling, but I will explain you just the meaning. What will be if I will increase or decrease temperature. If I will set temperature on the 0, I will have not Okay, I will have answers from the model, which would be similar from the training process. I will not give her I will not let her use imagination. And if I will set temperature to 1, I will let her use its own imagination, and her responses, would be not would be unexpected for me. So you can choose the way that you need the value that you need to set for the temperature by your own, and I think your tasks will apply on this value, and you can't know the okay, you can know the best values of sampling for your own checkpoint, but it will change for the time if you will have if you will fine-tune your model. Your sampling parameters will change in the future, and also you can't understand. You can't say for sure that you need use, for example, temperature of value of 0.6 all the time, and you will get good results, good responses from the model. It will change from the task you need to do, and for the checkpoint of the model, it would change also. Okay, so any questions?
No questions from my.
Okay, so okay, and also code Stral trained on over I said that it's 80 programming languages, but it includes Python, Java, C++, JavaScript, Bash, and other languages, code languages. So you can complete functions on different code languages. Also, you can ask it to generate code or code snippets, or completing functions, or maybe writing test, filling in incomplete code segments, and I wanna explain key features. So you can use multilingual preference here, like you can support a wide array of programming languages, making it for different development needs, and also you can generate code that fits between a given prompt and suffix, and also you can understand and execute natural language instructions to generate code. It can okay, there are practical applications that you can use. For example, code completion. It will assist in writing code by predicting subsequent lines or blocks based on the current context. Also, automatically generate test cases for functions. And maybe you can also convert code from one programming language to another. So okay, also I have exercise fill in the middle exercise, which shows its capability to generate a function. And we can, for the first step, set the prompt to the function definition. And here I wrote function. And then you can define the suffix, the code that calls the function and prints the sorted list, and use the fill in the middle endpoint to generate the function body. So here we can see on this use case, we can see how it will generate tests for this code segment. And also we can see another exercise of add and stop tokens for controlled output. So yeah, I defined stop as you can see that there is some space, and if the model will meet such of this token in the predictions, it will just stop its generation. So you will have some exercises here that you at home you can practice itself. But here I wrote the answer of fill in the middle example, but you can change it. You can change prompts, and also you can do some code generation in on this example. You can complete tests for function. You can try to generate the end of the function and maybe translate on another code language. For the last step that I want to discuss today, it's Pixtral. Pixtral is Mistral's multimodal model designed to process and understand both text and images with 12 billion parameters. Pixtral can handle tasks that involve a mix of visuals and language, such as interpreting charts, documents, or graphs. It supports variable image sizes and maintains state-of-the-art performance on text-only benchmarks. So usually I can explain you the main idea of multimodal large language models. You just need visual tokens and text tokens. Text tokens is initial. Okay, you will have embeddings from the texts, and you can use it in the predictions. Like, okay, I will show you the example. I think it will be more coherent in the discussions. Okay, look on the visualization. Here we have large language model, and it has her own tokens, and it works like just a decoder only transformer. We pass text to the model, we tokenize it previous, then we pass it to the model, we get embeddings in the embedding layer, and then we can process it. But if we will talk about multimodal large language models, we see that we need to pass also vision tokens to the model. And how to do it? we can use vision encoder. Usually it's a transformer-like encoder. We can use VIT, which encode image like, okay, here I need to show you it. Let's try to open this link, and we will see an image. So here we can see image from the Paris. So what I want to explain you, if I will encode this image with vision transformer, I will encode it. Okay, I want to encode pixels, but I can't because you know that transformer process sequences. So I need to create patches from this image and process it like a sequences. And I will have like blocks of image, and I will say that it's my patches. And then I can process it with a transformer and pass these patches like values to the model. Then I will have sequences, and then I can process it with the transformer model. I think it's a little bit hard to understand it right now. And I don't know, did you have computer vision in your program? I think maybe it will be more convenient to understand it if you learned computer vision.
Yeah, we're currently studying it.
Yeah, okay. So you know that with the convolutional networks, you process image, you have like pixels, and you pass to convolutional networks it from the variables. You have arrays with values and like attenders, and you pass it to the model. Here I do the same, but I use patches. And yeah, here it's visualizations, a visualization of patches. You see that it just blocks from the image, and then I pass, I have image, it's like a matrix, but here I need to pass it to the transformer model like a sequence. So I go in through all the blocks of image, and then I will have a positional encoding too. So it's not really important for this lesson, but I want you to understand how what is going on when we discuss multilingual, so multimodal large language models. And yeah, if I will return to the multimodal large language models, here I will have embeddings from the image with a vision encoder like VIT. Then I will have projection. Projection is usually just linear layer, and you can train it to combine vision embedding with textual embedding. That's it. And then you will have this layer will output the result, and you can pass it to the like you had sequence from the text, and you can pass it next for the next tokens to the model. Did you get like the intuition of this meaning of how does it work? But it's not really necessary for our program. Did you understand something?
Kinda.
Yeah, we got it. Thanks.
Yeah, okay. If you want more information, let me know. I will I will create links in the chat, Telegram chat, and maybe it will be a convent for understanding more details. Also, maybe then we will have some lectures about multimodal models, but I don't know. Okay, so let's continue. We understood meaning of multimodal model. So it's handle tasks that involve a mix of visuals and language, such as interpreting charts, documents, and graphs. And let's discuss. Okay, we can mention performance on text-only benchmarks, for example. And there are key features of this model. We can multimodal process it. So we will simultaneously analyze textual and visual inputs, enabling complex data interpretation. Also, here model have a large context window. It's kind of 128,000 tokens, allowing for the analysis of long and complex documents or multiply data sources. Also, variable image sizes integrates images at their natural resolution and expect ratio, providing flexibility in input handling. And also we can analyze documents, extract information from scanned documents, PDFs, and we will look how we can do it. Also, we can analyze and explain data visualizations and data-driven decision-making. And we can answer questions based on combined textual and visual information. Let's see how does it works. So I showed you image that we had here, and model give us response what is going on this image. So it just created text about this image because we prompted her to do it. Okay, and Pixtral can analyze images provided via URLs and generate descriptive insights. We passed image URL. As you can see here, the model retrieves the image from the provided URL, and Pixtral analyzes the image and generates a textual description. Also, here I inserted exercise of use Pixtral to analyze an image for the check. Okay, here I can open this image and show you what is going on here. And you can see that it's just check. Yeah. And we can, yeah, received. So we can run it, and we prompted to say what is going on the image. So it's worked like OCR when if you now studying computer vision, maybe you had a topic of OCR, this one, and you know how does it work from convolutional networks, this task. But here it's okay, it's a multimodal large language model, it can work on multiple tasks via one unique architecture, kind of this. And yes, so we provided URL of the image and formulate the prompt asking Mistral to describe this receipt. And then we can use initial text to maybe analyze it on the next steps if we need it. So we covered a lot of topics today. And if we discussed on the previous lesson how to fine-tune Llama model with transformers library, today we understood how to work with the API, and on some projects, on some real projects, working with APIs is now more convenient. And a lot of companies use it. They don't need to fine-tune on their own data. They need just prompt it, sometimes do extra techniques, which we'll discuss on 2 next lessons. Or no, we will discuss it in 3 lessons. In 3 lessons, yeah. And okay, they do RAG, like retrieval augment and generation, and then they don't need to fine-tune on their own documents. They can use it from the embeddings. I will explain you this topic yeah, in 3 weeks. And also sometimes they do in context learning. In context learning, it's learning from the prompt that you pass to the model. It means that you just in context sometimes show the model how to solve the tasks, and then you get the response which is similar on the response that you wanted to get. So do you have questions? Maybe questions for these lessons, maybe questions for other topics. Feel free to ask something.
No questions from this.
Okay, if you don't have, so this notebook is I pushed it to the GitHub repository in the branch yeah, in this branch, and also I created some directories for 2 next lessons for advanced topics, advanced techniques, sorry. We will discuss PEFT on next lesson, and you can find this notebook on the 8-week in large language model topic. And also you can download slides. We will discuss this lecture on Friday. So if you don't have any questions.
Sorry, could I ask one question about homeworks?
Yeah.
So could you please tell what is the most convenient way to train our neural networks? One way is to train it like in example in the notebook, where we when we write our own training loop, And the second way, when we use just Hugging Face framework and train it by its built-in tools.
It would be okay for me if you will train it via Hugging Face library, because I usually do the same. Okay, let me see. I wrote it. I wrote. How does it name? When I sent homeworks to you, I wrote all the. One second, I search for this and then I will tell you, because I can't do it simultaneously.
Yeah, sure.
Yeah, criterias of homeworks. Let me see what is there. 1 second, I will demonstrate the screen again. So here I wrote that it will be 2 points for implemented additive attention mechanism, 2 points for multiplicative, 2 points for setting up BERT model correctly, evaluating the model. In this case, that you need to implement additive and multiplicative attention mechanism, it would be convenient to you to train it like in the example, because okay, do whatever you want, but it needs just to pass all the steps. For me, it's no difference how you will train this model. Usually, I use Hugging Face Trainer too, and it's okay for me.
Yeah, okay. Thank you very much. And about maybe production cases, do you use it in production, like Hugging Face framework?
No, usually not, because I will explain you why. Because okay, you can use it if you have research projects and you need to you have hypothesis, and you can do some you can train model and then check is it good or not, measure it, and do other actions. But if and in this case, it's okay to train it via Hugging Face Trainer. But if you have production code and you need you need train model, and usually you need to optimize it. It's not convenient when you use Hugging Face Trainer if you want to use something extra that you haven't got there. They have difficult initial code, raw code in their library. And if you want to use some new quantizations of the model, or another some new features that didn't implement engineers in the initial library, it will be not convenient for you, and it will be really difficult to implement it by yourself. In this case, when I worked in big companies, we used our own pipeline of fine-tuning models, and now we usually okay, we just implement papers, but usually we if we have code in initial paper, we use the same pipeline of training that they had. If we start our research project by only begin with the idea, we write code pipeline of training just with PyTorch, because we need then to deploy it, and we need to use some optimizations of the model. We usually use some external frameworks for optimization the model, and it's convenient for us.
Okay, thank you very much for the answer.
Yeah, you're welcome. If you have some more questions, you can you always can text me in the Telegram. Okay, feel free to do it if you have some questions, not about the program, but maybe you have questions about projects and other topics of deep learning. Okay, guys, have a good evening. Thank you so much for your attention. See you on Friday.